If I were to ask you what is a React component, it wouldn't be unreasonable for you to say something like a function that returns some UI. And if that were your answer, though directionally correct, technically you'd be wrong. The more accurate description would be a function that returns a description of the UI. Though that seems pedantic, it's an important distinction. For the former to be true, we'd have to be returning literal HTML. Clearly that's not the case because we can't literally have HTML inside of a JavaScript file. But if we're not returning HTML,
what are we doing here?
Meet JSX, the magic behind having HTML-ish looking syntax directly inside of your JavaScript files. For the most part, writing JSX should feel pretty natural. It's mostly just like HTML, but there are a few things to be aware of. Up until this point, whenever we've had multiple elements in our JSX, we've done something like this, where the first element immediately follows the return statement and the rest are indented normally on new lines. Though that works, admittedly it's a little weird. We would never write HTML with the first element indented more than its children elements. So why do it here? To fix this, you might be tempted to do something like this. Unfortunately, that won't work. It's a fun quirk of the JavaScript specification that when the JavaScript interpreter runs this code, because of automatic semicolon insertion, it'll insert a semicolon right after our return statement, ending the function and returning nothing. The standard way to fix this is to wrap your JSX inside of parens, which allows you to have your JSX indented as you'd expect while avoiding AST issues. So far, so good. But here's a question I want you to think through. Can you spot any issues with this component? It looks fine, right? Unfortunately, it'll throw an error. This is a fancy way to say that you can only ever return one top-level element from a component. In our example, we're trying to return two, a header and an unordered list. To fix this, as the error says, we want to return one, which we can do by wrapping everything in a div. That fixes the problem, but now we have a semantic problem. We're unnecessarily creating an extra div. This is the exact use case that fragments were created for. If you want to return adjacent elements but don't want to change your markup, wrap them in a React.fragment element. There also exists a shorthand syntax for creating a fragment, but it feels a little too magical to me, so I don't use it much. Let's do another one. Can you spot what's wrong with this JSX? If you're familiar with HTML but new to React, your answer is probably nothing. This is another case where JSX is slightly different than the HTML spec. Whenever you have a self-closing tag, the most popular being input, BR, and image, you need to make sure that you explicitly close them. So with that, our form component will now have valid JSX if we explicitly close all of our self-closing elements. How about this one? Can you spot what's wrong with this JSX? I know this is a weird one. The error is that class should be class name. The reason for this is because eventually this JSX gets converted into JavaScript, and in JavaScript, there are particular keywords that are reserved. Class just happens to be one of those. A similar thing to look out for is that you can't have variable names that have a dash in them. So any normal HTML attributes that have a dash in them need to be converted to camel case. Also, whenever you want to use an expression inside of JSX, an expression being a fancy way of saying something that produces a value like a variable or a function invocation, you need to wrap that expression in single curly braces. If you want a React component to show nothing, as sometimes is the case when data is still loading, return null from the component. Next, let's talk about conditional rendering. The ability to conditionally show UI based on a piece of state is pretty foundational to any front-end framework. Typically, this functionality is built natively into the framework itself. With React, it's a bit different. Instead of increasing the API surface layer, because JSX is just JavaScript, React can leverage native JavaScript features to accomplish the same task. There are pros and cons to this approach, but if you're already familiar with conditional rendering in JavaScript, you'll feel pretty comfortable. Again, because we're just writing JavaScript, if we had another condition, we would just add an else if case. And if you're rendering different UI based on a single condition, typically you use JavaScript's ternary operator. Now we learned earlier that any expression needs to be wrapped in single curly braces. We can use that knowledge to render a ternary inside of JSX like this. Earlier, we also learned that we can return null if we want React to render nothing. This is a common pattern when using ternaries. Another common use case of conditional rendering is using JavaScript's logical AND operator. If you're not already familiar with it, typically it's used in conditionals as an AND statement. In this example, it's important to note that auth won't be checked if user isn't truthy. Using that logic, we can use the AND operator as a more concise ternary that renders null.
Concise, even rather eloquent.
Now, one question you may have had is how does React know the difference between a custom React component like user and a native HTML element like span? The answer is probably simpler than you'd expect. It's based on the capitalization. Whenever you create a React component, you need to capitalize it. Otherwise, React will think it's a native HTML element. So at this point, we're almost done, but there's one more thing about JSX we need to cover. Eventually, you come to accept that as an app developer, you have one job.
Making lists.
I write lists.
I worked long into the night, making lists.
So many lists, Father.
Lists are so fundamental that most frameworks come with a special API to build them. React, however, takes a different approach. When possible, React tries to keep its API surface to a minimum. To do that, it relies heavily on features that JavaScript provides out of the box. When rendering a list, the end goal, as seen in the Vue and Angular examples, is to create a list of list item elements that can be then shown to the UI. Can you think of anything built into JavaScript itself that would help us accomplish this? What about .map? Typically, you use map when you need to create a new array based on a previous array, something like this. Except now, instead of creating a new array of stars, we want to create a new array of list items. Using the same map method, let's throw in some JSX. Notice there's no new API to remember here. If you can remember how map works, you can remember how to create a list in React. Now, there is just one small addition we need to make to our code. Whenever you use map to create a list in React, you need to make sure that you add a unique key prop to each of the list items. It's React's job to make rendering the list as fast as possible. When you give each list item a unique key prop, it helps React to know which items, if any, have changed across different renders of the components. For the curious among you, you're probably wondering how JSX actually works. The next lesson is dedicated entirely to this question, but here's a quick teaser. In order to use React, at build time, you need a tool to transform JSX into normal JavaScript the browser can understand. So in a nutshell, JSX is just JavaScript, eventually.